The following data are available. Separation of the plates, RS. So this plate's R, that plate's S, is 4 centimeters, right? So that's R is 0.04 meters, right? The potential difference is 2.2 kilovolts, so that's 2200 volts, right? The velocity of the electrons is 5 times 10 to the 5th meters per second, right? So determine the strength of the magnetic field B. Okay, so what you're going to use in section 5.4, the first equation is that the force is QVB. Now there's a sine theta, but the angles here are all 90 degrees, so we can ignore the sine theta. So we're going to say QVB, and then we're going to use, so this is by the way 5.4, the first formula in that section. And you should practice finding these in your data packet. And then in 5.1, the fifth equation is that E is F over Q, right? So therefore force is EQ, right? So this is 5.1, the fifth equation. Okay, these are sections in your data packet, right? So that's going to equal E Q. So as long as charge is not zero, we can divide by Q, right? So the Q's will cancel here, okay? And we want to find B. So here's your velocity. You're going to plug that in for your velocity, right? And then the question is, what's our electric field? Well, if you look on page, geez, where is this thing? It's in 10.2, right? So equation, here we'll partition that off. 10.2, and this is equation. I call it the fourth equation, okay? Is that electric field is negative the change in voltage over the distance, right? There's changes in both of these guys, right? Okay. The electric field is the voltage divided by the distance, right? Okay, so what you're going to do is you're going to plug in for that the voltage here divided by the distance, right? And the distance is this, right? Right, and then the voltage is, of course, this. Woo, woo, right? So plug in 2,200 volts for that, plug in 0.04 meters for that, plug that in there, plug this velocity in there, solve for the magnetic field. I got something between 0 and 0.5. Happy hunting.